Hello guys. So in the series of tutorial we are learning about transaction. Okay, so now we are learn about what is serializability. Okay guys. So basic assumption each transaction. So guys, that means each transaction which are interacting with database must be preserve our database consistency. So if our particular transaction following the four properties, asset properties, atomicity, consistency, and isolation, durability, all the four properties, they must be preserved our database to be consistent. So our main goal is to consistent. Okay. Thus, serial execution of a set of transactions preserves database consistency. So, if you know that in our schedule 1, okay guys, and schedule 2, both are serial in nature. Okay guys, you can see this is T1, this T1 and this T2. First T1 is completed, then T2 is completed, like serially executing. First completes followed by second, then second completed, then followed by third, and so on. In this manner it is concluding. So conclusion of the story is a possible concurrent schedule is serializable if it is equivalent to a serial schedule. So you can see this T1 and T2, T1 T2 transition. First it is completing, after following it is completing. If we divide this transaction in two parts, one here, and this also sent in two parts, this here, then first these three steps will done, after that these four, after this these four, as soon as in this manner both full schedule is running. So due to this, so this is concurrent transaction, parallelly two transaction executing. Okay guys, and this is serial schedule. First it complete, second it complete. So if we prove, and serial schedule guarantees the consistency, because we have it. If this transaction following asset property it is also, then absolutely our DBMS database will be absolutely consistent. Okay, after and before. But if it is unconcurrent, okay guys, so we can't say that it is consistent or non-consistent. It can both, but we have to check if this transaction is equivalent to our serial schedule, then we say this concurrent transaction will be our what, consistent. But if it is not equals to serial schedule, not equivalent to serial schedule, then it is not consistent. Okay guys, so that what these two lines are saying. Okay guys, so different form of schedule equivalence give rise to the notion of. So we have two types of serializability. One is conflict, another is view. So guys, you can see simplified views of our transaction. We ignore operation other than read and write instruction. So we ignore that in our processor. Okay, there are many processes are running it. We only giving attention to database operation, and database operation we only denote these two, read and write. Okay guys, we can read from database and we can write in the database. Okay, so only two processor will run our processor, and we only know in DBMS only these two instruction. Okay guys, other applications happen in memory or temporary nature, mostly do not affect the state of the database. So what happen in our main memory, and this will not affect to the our state of the database. This is simplifying assumption of analysis. By applying this assumption, we can do analysis much more easier, because we are removing all the unconditional, important things from, so that we can easily analyze it easily. We assume that transaction may perform arbitrary computation on data in local buffer in between reads and write. If we are writing read a, okay, write a, all these things happening in our main memory, we have discussed in previous. Main memory have a small part buffer in which we are doing all the read and writes. Okay, after completing our all instruction, till we are not committing, all the instruction are in main memory. Till when we applied commit, at that time all the information which is written in main memory in buffer, which will copy it into our database and delete from the main memory. Okay, our simplified schedules consist of only read and write instruction. So we have seen in the previous, only read and write operations are there, nothing else. Okay, now first conflicting. Which instruction are conflicting in nature? Okay, so let us suppose we have ij and ijb, two instruction of transaction ti and tj respectively. Okay, but suppose we will discuss instruct ij and ij conflict if and only if there exists some item q accessed by both I and ij, and at least one of these instruction write q. So guys, see here, this is T1, T2, two transaction. These all are II instruction. These all are IJ instruction. That means T1 instruction are II, T2 instruction are IJ. If II means write A, first we read A from our database. Okay, we write A in our database. Okay, suppose anything, when we read A, its value is 10, but after writing A, its value become 100. Okay, so we write 100. Now when T2 read A, that time it is not reading from database, it is reading from write A. Whatever written in main memory buffer, we write A in our main memory. So read A will be read by main memory, so it become 100, but actually in database it is 10. Okay guys, so 100, and again write A, read A 100, and it's write it to 1000. So again it returned the information. That means it is 10, but it's now 1000. So use difference. Okay guys, so that's about conflict. Okay, so if you are seeing, like, here is read, here is read, no conflict at all, because by reading there is no confliction. We are seeing only, um, like, suppose, you can see, there is example. Yeah, suppose, wait, yeah guys, you can see here is read A, it is from database. Okay, read A from database. Now there is no write operation. Again read A, so it is also reading from database guys, there is no write operation here. So both values are reading from database, so no problem at all, means no conflict. Okay, but problem comes here, read B. Okay guys, and write A, means we have read something and write, but these are two different variables. B and A are different variables, so there is no problem. Okay, now you can see here is write B and here is write B. We will see one instruction from here, one instruction from here, and here write same variable B B. That means there will be confliction. Up now we check. Okay, write B. Here we write 10, here we write 100. Both confliction. So that's confliction. Okay. So now we have seen read, don't conflict. Okay. Read, write, conflict. right to it conflict, right?